compound A and B react together to form an equilibrium mixture containing compounds C and D, according to the equation shown. A beaker contained 40 centimetres cubed of 0.16 mole per decimetre cubed aqueous solution of A, and then we've got a moles of B and moles of C, and it was left to reach equilibrium, and then it tells us at equilibrium how much A we've got. So the first thing that we need to do is actually the very first amount of A is not in moles, and we need everything to be in moles to be able to look at the ratios in the equation. So let's turn that into moles. So that's our first thing. If we type that on our calculator, we'll get 6.4 times 10 to the minus 3. Now I'm going to use the Rice method to work out the equilibrium moles. So this is like where we look at the ratio, which is 2 to 1 to 3 to 1. The initial amounts, so we've just worked out that that's 6.4 times 10 to the minus 3. It told us that B was 9.5 times 10 to the minus 3, and that C was 2.8 times 10 to the minus 2. Be careful of that standard form. There's no D at the beginning, so I haven't mentioned it. And then we're going to figure out the change and the equilibrium amounts. Now, we've been told at equilibrium that there's 3.9 times 10 to the minus 3 moles of A. So the first thing we need to do is work out what this first change is. So if we look, we've got 6.4 times 10 to the minus 3 minus 3.9 times 10 to the minus 3. So this has gone down by 2.5 times 10 to the minus 3, which means that B, because our ratio line and our change line are in the same proportions, and if 2.5 is equivalent to 2, then the ratio of 2 to 1 means that we're going to go down by half of that, so 1.25 times 10 to the minus 3. So if we can apply that, 9.5 times 10 to the minus 3 minus 1.25, we'll find that the equilibrium amount of B is 8.25 times 10 to the minus 3. Now C is going to go up 3 times as much as B went down, because the ratio is 1 to 3, so we're going to add 3.75 times 10 to the minus 3, and D is going to go up the same as B went down. So D is an easy one, so you don't need my calculator, but I'm going to add up the other one. Just watch that standard form. One of them's times 10 to the minus 2, and one's times 10 to the minus 3. My calculator's giving me 0.03175. So I can put my answers on the line. 8.25 times 10 to the minus 3. 0.031. I could write 75. I could round up to 318 because 3 significant figures in the rest of the question. At this point, it wouldn't matter. Now it wants us to give an equilibrium constant. So Kc equals, now remember that Kc is a fraction with the concentrations of the products on the top. So that's C and D. So square brackets essential. There were 3 C's, so raised to the power C times C times C, 3 C's, times by D. There was only 1 D. And then there were 2 A's and 1 B. The square brackets are essential. Now we need to figure out its units. So we've got 3 and 1. We've got 4 concentrations terms on the top, 3 C to the 3 and D to the 1. And we've got 3 on the bottom. So powers, when you divide powers, you subtract. So we've got 4 take away 3 is 1. So this has just got the units of concentration, which are moles per decimetre cubed. Now, it's given us a different equilibrium mixture of these 4 compounds. So let's just rewrite our expression so we can just remember it. And we're on a different page. So it was C cubed times D over A squared times B, all concentrations. Everything they've given us is moles. So we're going to need to convert moles to concentrations, which is why we need this volume. But they've given it as 5 times 10 to the 2, which is 500 centimetres cubed. Now, if we convert that to decimetres cubed, we'll see that that is 0.5 decimetres cubed to allow us to calculate concentrations. So it says Kc is 116. Okay, and then C, 0.076 moles, but we're going to divide that by 0.5 and it's cubed. And then D oops, that's the wrong one, that was D. C was 1.05, D was 0.076 over 0.5. A is what we're trying to find, so we've still got A squared there, and then B is 0.21 over 0.5, not squared there. So now what we've got to do is rearrange to get A. So I'm just going to bring A squared up off the bottom line and take KC down. So I'm not going to actually work out this yet, but in a minute we'll type all this into your calculator. Okay, so if you type all that into your calculator, you can get a value for A squared. And if you type that in, you get 0.0289. So then if you square root that, you will get the concentration of A. And it does actually want us to give it to the appropriate number of significant figures. And if we look, we've been given a few things to 3, but a couple of things to 2. So we do want to give our final answer here to 2 significant figures. And if we square root it and give it to 2 significant figures, we see we're getting 0.17. When we add more water, so when you add water, all the concentrations decrease. So all the concentrations decrease. What will happen then is you're going to shift to the side with the most moles to increase the concentrations more, to oppose that decrease. So equilibrium will shift to the side with more moles to oppose that decrease in concentration. So shifts, so if we go back and look at our equilibrium, it's quite a long way back. It's going to shift to the side with the most moles, it's going to shift right. And A decreases.